Chapter 7's focus was all about adding and subtracting fractions and mixed numbers. So let's go ahead and we're going to review all of what we learned in Chapter 7. So one of the first things we learned is we talked about writing fractions as the sum of unit fractions. Now remember, a unit fraction is a fraction with a 1 in the numerator. So I want you to go ahead and I want you to write 4/6 as the sum of unit fractions. Remember, sum means we have addition going on. So what would 4/6 look like as the sum of unit fractions? So if we were writing 4/6 as a sum of unit fractions, we would have to have 4 unit fractions with a 1 in the numerator, because our unit fractions have our 1s in the numerator, so we'd have 1/6, 4 times adding them together. Show 5/7 as the sum of unit fractions. So 5/7 as the sum of unit fractions, we would have 1/7 plus 1/7 plus 1/7 plus 1/7 plus 1/7 plus 1/7. So we'd have 5 1/7, and we know that these are unit fractions because they have 1s in the numerator. That's what's important about unit fractions, is that they have a 1 in the numerator. All right, next thing we talked about was taking our mixed numbers and turning them into fractions, and then we turned fractions back into mixed numbers. Now there were two different options that we could use to do this. Option number 1, we would take our 3 2/5 and we would pull out our wholes. A whole in this case would be equivalent to 5/5 because my denominator here tells me that my wholes are split into 5 equal parts, and my whole number tells me I have 3 of them, so I would have 3 5/5, and then I would have my 2/5, and when I add all these together, I'd add my numerators up, so 5, 10, 15 plus 2 more would give me 17/5, and this would be my fraction. Option number 2, we did some multiplication and then some addition, so we would still have 3 2/5, and our first step would be to multiply our whole number times our denominator, so 3 times 5, and that gives me 15. To our product, or the answer to our multiplication problem, so our 15, we would add our numerator, so we're going to add 2 more, and that's going to give us 17, and this 17 is our new numerator, so we rewrite it as a fraction. Our denominator of 5 stays the same, and our new numerator goes up at top. So we get 17/5. Either way you do it, you get the same answer. Go ahead and change 5 1/7 into a fraction. When we change 5 1/7 into a fraction, I'm going to do multiplication and then addition. So 5 times 7 gives me 35, and then 35 plus 1 more gives me 36. This becomes my new numerator. So I have 36, and my denominator of 7 stays the same. All right, go ahead and change 4 3/5 into a fraction. So for this problem, I'm going to go ahead and I wrote my wholes as my fraction. So because my denominator is a 5, each whole is equivalent to 5/5. So each of these 5/5 is equal to 1 whole, and then I have my 3/5. In order to turn it into a fraction, I have to add up my numerators. So 5, 10, 15, 20, 23, and then my denominator stays the same. Next thing we did was we turned fractions into mixed numbers, and we did this one of 2 ways. The first way that we could have done this was by pulling out our wholes. So if we had 15/6, 1 whole would be equivalent to 6/6 because my denominator is 6, so that tells me each whole has 6 equal parts. And then I'm going to add fractions until I get to 15/6. So 6 plus another 6 is going to get me 12. I can't add 6 more, so I can only add 3 more. And then I'm going to rewrite this as a mixed number by pulling out my wholes. So I have 1 whole, 2 wholes, and then my 3/6. And that's rewriting this as a mixed number. The other way that I could do this, option number 2, is through division. So I'd have 6 into 15. 6 goes into 15 2 times. 6 times 2 gives me 12. I subtract, and I'm left with a remainder of 3. When I'm changing this into a mixed number, my quotient, my answer to my division problem, becomes my whole number. My remainder, which is my 3, becomes my numerator, and my divisor of 6 becomes my denominator. Either way, I get the same answer. I have 2 for you to practice. So we have 17/4. Go ahead and turn that into a mixed number. So I chose option number 1 for this one, where I pulled out my wholes, and I have 1, 2, 3, 4 wholes, and I'm left with 1/4 as my fraction. And how I did that was by adding all of my numerators. So if I add 4 plus 4 plus 4 plus 4, that gives me 16, plus 1 more gives me my 17 that I started with. Go ahead and turn 21/5 into a mixed number as well. For this one, I'm going to choose option number 2, so I'm going to do some division. I have 21 inside of my division house, and I'm going to divide. 5 goes into 21 4 times. 5 times 4 gives me 20. I subtract, and I'm left with a remainder of 1. I'm then going to turn this into a mixed number. So my quotient becomes my whole number, my remainder becomes my numerator, and my denominator is my divisor. So 4 1/5 is what 21/5 is as a mixed number. So you have those two options for either way. Now, one of the last things that we did is we added and subtract our mixed numbers, and when we did that, we needed to make sure that we regrouped. When we were adding, if we ended up with a fraction equal to or greater than 1, we needed to regroup and add that to our whole numbers. If we were subtracting, sometimes we needed to regroup there. So I'm going to go ahead and do the first one, and then we're going to go ahead and we're going to practice a few. So when we add 3/4 plus 2/4, I end up with 5/4, and then I'm going to add my whole numbers and I end up with 5. Now the problem with this is that my 5/4 is a fraction greater than 1, and I can't have an answer with a fraction greater than 1. So I need to do a little bit of work with this problem. So I'm going to go ahead and I'm going to pull out my whole, and then I have 1/4 remaining. And 4/4 is equal to 1 whole. So I'm going to take that 1 whole and I'm going to add it to my whole number. And so my final answer is 6, because 5 plus 1 gives me 6. And then I have my 1/4 left. So 6 1/4 is my answer to this addition problem. Go ahead and add 5 6/7 plus 4 5/7, and don't forget to regroup. When we add, we end up with 9 11/7, but we can't leave it like that because our 11/7 is a fraction greater than 1. So we need to pull out our whole of 7/7, and then 7 plus 4 gives me 11. And I know that this 7/7 is equal to 1 whole, so I'm going to add my 1 whole to my 9, and I'm left with 10 wholes, and then I can't forget about my fraction of 4/7, so I bring that down. Now our next problem is a subtraction problem, and you'll notice that we have a whole number of 8, and then we're subtracting 4 1/3. Now when we do this, we can't forget about this fraction that's missing. We don't have a fraction there. Now if we're taking a third away, we need something to take a third away from. It's important that we subtract our fractions first and then our whole numbers. So what are we going to put in this blank, and what are we going to do to be able to put something in that blank? Well, to be able to put something there, we have to regroup. So we're going to borrow from our 8, and it's going to become a 7, and then we're going to put a whole there because my denominator of my fraction below shows me that it's a 3. I know that 3/3 is going to be my whole, and it's important that we subtract fractions with the same denominator. So if I chose a different fraction and it had a different denominator, we'd have a little bit of work to do. So I have my 3/3, and now I can start my subtraction. I'll go ahead and subtract. 3/3 minus 1/3 gives me 2/3, and then 7 minus 4 gives me 3, so I'm left with 3 2/3. All right, we have 3 more problems for you. The first one is 3 1/4 minus 2 2/4. Go ahead and subtract those now. When we set this problem up to subtract, we notice that our 1/4 is smaller than our 2/4, and so we can't subtract right away. Instead, we first have to borrow from our whole and then add a whole. So now we have 5/4, and now we can subtract. 5/4 minus 2/4 gives me 3/4, and when I subtract 2 minus 2, I'm left with 0, so my answer is 3/4, and that's it. We have 5 and 6/7 minus 4 and 5/7. Go ahead and subtract that. This one's pretty simple. My numerator, or my fraction on top, is greater than my fraction on bottom. So I just go ahead and subtract, and I'm left with 1/7, and then 5 minus 4 gives me 1, and I'm done. No regrouping necessary for that one. The next one's an addition problem, 8 and 2/3 plus 4 and 1/3, so go ahead and add. When I add my fractions, I'm left with 3/3, and then I add my fraction, or my whole numbers, and I have 12. Can I leave it like this? I cannot leave my problem like this because 3/3 is equal to 1 whole. So I need to do some regrouping, and when I add that 1 whole to my 12, I'm left with 13 as my final answer. We have a little bit more to get through. Our next section is adding 3 mixed numbers together. And we talked about in class, one of the best ways to do this is to add all of your whole numbers, add all of your fractions, and then do some regrouping. So go ahead and do that. Sometimes it's best to see if you can find your whole. So 4/5 and 1/5 make a whole, and then all I'll be left with is 2/5. If that's a way that you can look at this problem and dissect it, you are welcome to do that. I'm going to go ahead and add all my wholes. So I have 3 plus 6 plus 8. And when I add 3 plus 6, I get 9 plus 8 is going to give me 17. Notice how I didn't try and add all 3 of those numbers at once. I just took it step by step. My next step is to add all of my fractions together. So 2/5 plus 4/5 plus 1/5. And I noticed already that these two fractions are going to give me 5/5 and then 2/5. Well, 5/5 is equal to 1 whole, and then I'm just left with 2/5 after that. This way I don't have to add and then regroup. If I did add and then regroup, I would have 7/5, and then I'd have my whole of 5/5 plus 2/5, and again it would equal 1 and 2/5 regardless. My last step is to go ahead and add my mixed number and my whole number together. So 17 plus 1 and 2/5 means that I have to add my 1 and I have to add my 17. And when I do that, I'm left with 18 and 2/5 as my final sum. So again, our steps are add our whole numbers, add our fractions, turn them into a mixed number, and then the final step is to add them both together so that we get our final sum. All right, our next problem, again, add those 3 mixed numbers together. I'm going to go ahead and add my whole numbers. It doesn't matter which way it adds. I'm going to add my smaller numbers together, and then I'm going to add 7 plus 6, and I get 13. I'm then going to add my fractions of 3/6 plus 5/6 plus 4/6. And when I do this, I end up with 12/6. When I regroup 12/6, I notice that there are 2 6/6 in 12/6, or 2 wholes. So I'm going to take my 2 wholes and I'm going to take my 13 and I'm going to add those together. And 13 plus 2 more gives me 15 as my final answer. Doesn't have to be a mixed number if it doesn't end up being a mixed number. All right, we have 2 final problems to do, 2 quick word problems. Lance has 5 1/6 yards of fabric and needs 3 4/6 yards to make a costume. How much extra fabric will he have left over after making the costumes? What type of problem are we working out? We have a subtraction problem, so we have 5 1/6 minus 3 4/6. Go ahead and solve this problem to figure out how much extra fabric Lance will have left over after making the costume. In order to solve this problem, we have to do some regrouping. So we borrow and then we add a whole. Our whole is equivalent to 6/6 because our denominator here is 6, which tells us there are 6 equal parts in my whole. I then subtract 7/6 minus my 4/6, which is right here, and I end up with 3/6. And then I subtract 4 minus 3, and I have 1. So how much extra fabric will Lance have after making his costume? He'll have 1 3/6 yards. You could also regroup this or simplify this. Our 3/6 is equivalent to a half, so we could also say we have 1 1/2 yards of fabric left. And last problem. To make a fruit salad, Faith mixes 3 2/5 cup of blueberries, 1 3/5 cup of raspberries, and 2 4/5 cup of strawberries. How many cups of berries are in the fruit salad? In order to solve this problem, we need to add all three of our mixed numbers together. So we have 3 2/5 plus 1 3/5 plus 2 4/5. And when we add all these together, we're going to add our whole numbers. So 3 plus 1 plus 2, and that gives me 6. I'm then going to add my fractions, 2/5 plus 3/5 plus 4/5. And when I add all of those fractions together, I'm left with 9/5. I'm then going to regroup that. So I'm going to pull out my wholes. And when I do this, I have 1 4/5. And then I need to add my 1 4/5 and my 6 together. So 1 plus 6 gives me 7 4/5. So we have 7 4/5 cups of berries. All right, that's our review. Again, when we are adding, make sure that you regroup. When you're subtracting, make sure to check to see if you need a regroup. When we're turning our fractions into mixed numbers, you can pull out your wholes or you can divide. And then when we're turning our mixed numbers into fractions, we can create our wholes or we can do our multiplication and addition. And then a unit fraction is a fraction with a 1 in a numerator. That's our review. See you next time when we start Chapter 8.